Welcome to Eureka Math. I'm Mr. Schenkel. This is 8th grade math, Module 4, Lesson 4. Let's get started. Okay, before we do our work today, first of all, we have to solve the linear equations given and state the property that justifies our first steps. And in order to do that, we need to know what those properties are. So I want to put this up so we can see it first. These are the properties that we're going to be talking about. On top of some basic things like commutative property, distributive property, combining like terms. But then when we go about solving the equation, solving for x, we're going to be using these properties. And we talk about the addition property of equality, which just says if we add the same number to both sides of an equation, the equation will remain equal. It will remain balanced. So whatever I do to one side of the equation, I have to do to the other, whether it's addition, subtraction, multiplication, or division.
Can I have your attention, please? Damian Younger to the office, please.
All right, you didn't need to know that. All right. Anyway, we're just trying to balance the equation. So we're going to use these properties strategically to undo certain operations that are happening so that we can isolate the variable and find out what x is equal to. All right, so let's get those out of the way for now, and we'll remember what they are as we go. Here we go, number one. We've got a very long expression on the left side and then just a constant on the right. So what I'd like to do is simplify this as much as possible and get rid of as many terms as I can before I go about solving for x. And that just means combining like terms. So I'm just going to go through and try to find all of the terms within x. And I can see there's one there, and there's another, and there's 3, and there's 4. So 4 x's, that's 4x. And then I see a constant positive 2, and I see a constant positive 4, and I see a constant positive 6. So add all those together and we get 12. So that's 4x and a positive 12 is equal to negative 28. So what we've done so far is just use, we've just combined like terms using the distributive property, putting those all together so that it's simplified down to a 2-term expression on the left side and a 1-term expression on the right side. And now I'm just interested in isolating the variable. So we're going to use those properties of equality to isolate the variable and find out what x is equal to. So the first thing we do is undo addition or subtraction first. It's like the order of operations backwards because we're undoing it. So 4x plus 12, I'm going to subtract 12 from the left side so that the positive 12 will be canceled out by the negative 12, and I can be simplified on the left side to a 4x. Now remember, whatever you do to one side, you have to do the exact same thing to the other side in order to keep the equation in balance. So a negative 28 and a negative 12 put together is a negative 40. And now we still have a balanced equation. Both sides are still equal, but we're a little closer to isolating the variable x. The next thing I would do is undo multiplication. And you may have learned in the past to undo multiplication with division. Just like this, that certainly works. 4 divided by 4 is 1x. Negative 40 divided by 4 is negative 10. You can certainly do that. I'm going to show you a different way because we're going to be dealing with a lot of fractions. And that doesn't work for fractions. We can't divide by a fraction. In fact, it's not mathematically defined. So we have a workaround, and the workaround is instead of dividing by, let's say this is 4 over 1, instead of dividing by a fraction, we can just multiply by its reciprocal. And if we multiply by its reciprocal, now we can actually do that math using fractions, and it essentially does the division for us. So for 1 times 4 is 4, 4 times 1 is 4, 4 over 4 is 1x. Or the 4's cancel, the 1's cancel, I'm left with what I want, and that's x. On the right side, I get negative 40 times 1, that's negative 40. And I get 1 times 4, that's 4. There's my division. Negative 40 divided by 4 is negative 10. You might be thinking, now that's a lot more complicated and more work when I could just divide by 4. But if you learn it this way, when we get fractions, you won't have to learn a different way. So that's why I'm showing you that way. All right, what properties did we use? Well, here we used the equality property of subtraction. And we did that to undo the addition that was happening right here. So we use the equality property of subtraction. When I subtract the same number from both sides, I get an equivalent equation. And then down here, we used the equality property of division by using a reciprocal and multiplying, kind of the same thing. Anyway, x equals negative 10 is our solution, and that is the only value for x that will make the equation true. Number 2. Well, let's see. 2 times the quantity 3x plus 2. I'm going to use the distributive property here to distribute the 2. So this is 2 times 3x, that's 6x, plus 2 times 2, that's 4. There's my left side, a binomial. On the right side, I can combine like terms. I have a 2x and a positive 1x. That's 3x and a negative 1. There's another binomial. All right. In this case, we need to get all of the variables on the same side. It doesn't matter which side. So I'm going to choose to subtract 3x from both sides so that I have a positive x value. So I'm going to subtract 3x from the right. I'm going to subtract 3x from the left to balance the equation. This leaves me with 3x plus 4 equals negative 1. And now I've gotten rid of that x on the right side, so I can isolate the variable and come up with our answer. All right. Next, I'm going to undo the addition first. So I'm going to subtract 4 from both sides. That's going to eliminate the positive 4. I get 3x equals a negative 5. And then I'm going to multiply by a reciprocal. Multiply by 1/3. Multiply by 1/3. And the 3's cancel. I get x equals a negative 5 thirds. And that's my answer. What properties did we use? Well, we used quite a few. Distributive property to begin with. We combined like terms. Then we used the, right here, this is the equality property of subtraction. So is this. And then we use the equality property of division or multiplication down here using the reciprocal. Okay, number 3. X minus 9 looks fine. 3/5 x looks fine. The only problem is we have x's on both sides. So let's see. I'm going to subtract the 3/5 x. So in order to do that, I'm going to call our x to begin with 5/5 x. Because 5/5 is 1, and I have 1x, so this is an equivalent expression. 5x minus 9 is equal to 3/5 x. And so first thing I need to do is get all of the x's on the same side. I'm going to do that using the equality property of subtraction. And that just means I'm going to subtract 3/5 x from the right side, and I'm going to subtract 3/5 x from the left side. And that gives me 2/5 x minus 9 is equal to 0. And now I can use equality property of addition to undo the subtraction. Let's do that next. I'm going to add 9 to both sides to balance the equation. That leaves me with 2/5 x is equal to 9. This cancels. And now, if we stay with undoing multiplication with division, I have a problem because I can't divide by a fraction. But this is where it becomes handy to multiply by reciprocal. So I'm just going to multiply by the reciprocal of 2/5, which is 5/2. Balance the equation by doing exactly the same thing. And let's see what we have. The 2's cancel, the 5's cancel. We get x equals 9 times 5 is 45 over 2. And that's our answer. X equals 45/2. It's the only value of x that will make this statement true. Number 4. Let's see, 29 minus 3x, can't do anything there. 5x plus 5, can't do anything there. All I need to do is get the variables on the same side again. So let's rewrite 29 minus 3x equals 5x plus 5. I need all the variables on the same side. I'd really like to have my variables have a positive coefficient. So in order to do that, I'm going to add 3x to both sides. Okay, that eliminates the negative 3x. I get 29 is equal to 8x plus 5. And now I can use my properties to isolate the x. So undo addition with subtraction, balance the equation. 24 equals 8x. These are canceled. And then multiply by reciprocal. Balance the equation. The 8's cancel. I get x all by itself, which is what I want. And 24 divided by 8 is 3. X equals 3 is the solution. Okay, what did we use? Equality property of addition right here. Equality property of subtraction right there. Equality property of multiplication or division in the last one. Okay, number 5. 1/3 x minus 5 plus 171 equals x. So I can simplify the left side by combining like terms. Let's do that first. I see a negative 5 and I see a positive 171. So a negative 5 and a positive 171 is 166 positive. So I have 1/3 x plus 166 is equal to x. Well, I would like my x to have the same denominator, so I'm going to call that 3/3 x. Now it's going to be easy for me to subtract to get all of my x's on the same side. So let's do that. I'm going to subtract 1/3 x from the left side. So that eliminates, and 1/3 x from the right side. To balance, these cancel. I get 166 is equal to 3/3 minus 1/3 is 2/3 x. And finally, I can multiply by reciprocal. The reciprocal of 2/3 is 3/2. Balance the equation. And the 2's cancel, the 3's cancel. I get x all by itself, which is what I'm looking for. And then I like to simplify before I multiply, so I have to think about simplifying a large numbers, large values. So I know that 2 goes into 2 once, and 2 goes into 66 88 times. And now it's just 3 times 88. 264? I hope. I didn't check that with the calculator, but I think that's right. If not, you'll let me know, right? You'll let me know. That's it. Using equality properties to isolate the variable and remembering to simplify each expression before we go about that work makes things easier. That's lesson 4. Hope that helps. See you again next time.